Over a decade of effort by the Marshall Space Flight Center and the Saturn Apollo industrial contractors was culminated this report period with two highly successful launchings of Saturn V vehicles for manned lunar landing missions, Apollo 11 and Apollo 12. On the morning of July 16, 1969, the sixth Saturn V flight vehicle lifted off from the Kennedy Space Center's Launch Complex 39B for the beginning of mankind's most historic undertaking, the first manned landing on the moon. The launch vehicle, designated Apollo Saturn 506, developed and manufactured by the Marshall Center and its industrial team, performed its mission almost flawlessly as it carried astronauts Neil Armstrong, Edwin Aldrin, and Michael Collins aboard the Apollo 11 spacecraft on their epic journey to the lunar surface. Engineering evaluation of flight data indicated no significant deviations from the flight program, with all mission objectives attained. The S-1C stage's center F-1 engine cut off at 2 minutes 15 seconds. The four outboard engines shut down at 2 minutes 41 seconds. All staging sequences were performed within seconds or even fractions of a second of their predicted times. Separation of the S-1C and S-2 stages occurred at 2 minutes 42 seconds into flight. S-2 ignition was achieved at 2 minutes 43 seconds. S-2 center J-2 engine cutoff came at 7 minutes 40 seconds into the flight, with S-2 outboard engines cut off at 9 minutes 8 seconds. Separation of the S-2 and S-4B stages occurred at 9 minutes 9 seconds, and S-4B ignition 0.2 of a second later. The first burn of the S-4B stage, lasting 2 minutes 30 seconds, established a circular parking orbit around the Earth of 103 nautical miles, precisely as planned. During the second revolution, the S-4B stage was reignited on schedule, 2 hours 44 minutes 16 seconds after launch time, for a 5-minute 44-second burn to achieve translunar injection. After transposition, docking, and ejection of the Apollo 11 spacecraft, residual propellants in the S-4B were used to increase the separation of the stage in spacecraft trajectories and to dispose of the stage into a solar orbit. The accuracy with which the S-4B second burn had sent the 3 astronauts on their moonward coast trajectory was such that only 1 of 4 planned mid-course corrections proved necessary. As astronaut Collins circled the moon in the spacecraft's command and service module, codenamed Columbia, other space travelers descended to the surface in their lunar module, the Eagle, landing at 3:18 p.m. Sunday, July 20th, only 4 miles from their predicted landing site. Some 6.5 hours later, Neil Armstrong became the first man ever to set foot on the moon. Edwin Aldrin followed the Apollo 11 commander some 20 minutes later. The two men spent a total of 2 hours and 32 minutes on the moon, taking photographs, gathering lunar material samples, and deploying scientific experiment packages. Then a perfect liftoff from the lunar surface, docking with the Columbia in lunar orbit, firing of the spacecraft service propulsion system engine for trans-Earth injection, the 59.5-hour coast back to Earth, 250,000 miles away, splashdown and recovery in the Pacific near Hawaii, all accomplished without mishap, and the historic mission, begun so successfully by the Saturn V launch vehicle 8 days earlier, had ended in triumph. Meanwhile, preparations for the second lunar landing mission, Apollo 12, were well underway at the beginning of this report period, as the 7th Saturn V flight vehicle underwent checkout in KSC's Vehicle Assembly Building during July, August, and early September. The vehicle was moved on September 8th to its launch pad. The astronaut crew for the Apollo 12 mission would be Charles Conrad, Richard Gordon, and Alan Bean. The flight readiness test was concluded on September 30th. The countdown demonstration test, last major test before launch, began on October 24th and was finished 5 days later. After final checks, the launch count was picked up on November 8th and proceeded with only a few minor problems. with the President of the United States and estimate 10,000 other spectators watching from the bleachers. Morning of November 10th, under dark and threatening skies which severely curtailed photographic coverage, AS-507 lifted off, disappearing almost immediately into the dark clouds. At 36.5 seconds, lightning struck the vehicle. This artist's concept, based on photographs of the lightning phenomenon, shows 3 bolts hitting near the launch platform. Another electrical discharge between clouds occurred at 52 seconds. Minor disturbances were recorded in the launch vehicle, but these had no effect on system performance. With photographic tracking footage unavailable due to weather, animation depicts the flight. Evaluation of flight data indicated that despite some unanticipated events, AS-507 accomplished all mandatory objectives, placing the S-4B stage and spacecraft into an accurate Earth parking orbit, and then sending the spacecraft into translunar trajectory. During S-2 stage burn, some reappearance of the low-frequency vibrations of previous vehicles was recorded. However, such vibrations did not persist long enough to produce fatigue effects, and qualification levels of components, such as valves, lines, and electronic packages, were not exceeded. Both first and second burns of the S-4B stage were successful. All guidance and control performances were as expected during second burn, with the stage being placed on the proper trajectory. As shown in this non-scale animation sequence, the S-4B stage was disposed of by using residual propellants to send it into a translunar orbit, with an apogee approximately 4 times the distance of the Moon from the Earth, and a perigee about 1/2 the Moon's distance. The 3 Apollo 12 astronauts arrived at the Moon on November 17th, going into a 54 to 66 nautical mile orbit. While Gordon remained behind in the Command and Service Module, codenamed Yankee Clipper, Conrad and Bean descended in the lunar module, Intrepid, to the lunar surface. Charles Conrad became the 3rd man ever to set foot on the Moon, with Alan Bean stepping down shortly afterward. The 2 men left the lunar module twice to set up scientific experiments and make geological investigations. Only 600 feet from their own landing site, they inspected the Surveyor 3 unmanned spacecraft, which had been sent to the Moon 2.5 years ago. Then ascent from the Moon's surface, docking with the orbiting Command and Service Module, the long voyage home to Earth, safe splashdown and recovery near Hawaii, all accomplished smoothly. Apollo 12, just as Apollo 11, a thoroughly successful mission. Meanwhile, the final portion, the instrument unit for the next Saturn V flight vehicle, 508, arrived at KSC from the contractor, IBM Huntsville, on July 7th. The other stages had been delivered in June. Erection of the AS-508 vehicle began in the Vehicle Assembly Building in early July and was completed on August 1st. During troubleshooting on the IU platform electronics assembly, a defective relay was discovered. The assembly was removed and sent to the Marshall Center for repair in late November, then returned 4 days later and reinstalled. Rollout was accomplished on December 15th. AS-508 will launch the Apollo 13 spacecraft in April on the 3rd lunar landing mission. The flight was postponed from its original March launch date in order to allow more time for scientific investigation between Apollo missions. The astronaut crew will be James Lovell, Thomas Mattingly, and Fred Hayes. After the S-4B stage of 508 pushes Apollo 13 toward the Moon, it will be purposely crashed on the lunar surface. A seismometer left by Apollo 12's crew will measure the impact as part of scientific investigations to be conducted during the mission. At the Mississippi Test Facility, recovery from the S-1C-11 fire of late June was rapidly effected, with test stand refurbishment and development of workaround procedures allowing continuance of test operations without major delays. Cause of the S1C-11 fire was determined to have been failure of a technician to remove a polyethylene disc dust cover in a duct leading to one of the engines. The damaged stage was returned to the Michoud assembly facility in July for engine removals and refurbishment. Fire-damaged components of the S1C-11 stage are shown in this display at the Michoud facility. In mid-August, Hurricane Camille hit the Mississippi coast with devastating fury, causing damage at MTF estimated to be approximately $750,000 and delaying test schedules for several weeks. Damage to Saturn V flight stages either in storage or in position in the test complexes was very slight. A thorough inspection assured there were no leaks, electrical shorts, or other defects. MTF's static firing schedule was resumed without impact to Apollo launch vehicle schedules. The S2 stage for the 10th Saturn V flight vehicle was successfully test-fired in late September. S2-11 was tested in mid-November. The S1C stage for the 12th flight vehicle was successfully fired at MTF in early November. At the McDonnell Douglas, Sacramento, California test site, acceptance firing of the S4B stage for the 10th flight vehicle was performed in August. Static testing of the 11th flight stage occurred in December. At NASA's Edwards test site in California, acceptance firing of the final F-1 production engine was performed in September under the Rocketdyne contract supporting Apollo launches through AS-515. Engine activity at Edwards is now reduced to one test stand for operation support and test of repaired or refurbished engines. Fabrication and assembly work by Boeing is progressing at Michoud on S1C-13, 14, and 15, last of the currently contracted stages. Also at Michoud, the final Saturn 1B first stage, S1B-14, was completed by the contractor, Chrysler Corporation Space Division, and was placed in storage in late July. Chrysler will maintain a support force at the Michoud facility. At the S2 stage contractor plant, the Seal Beach, California facility of North American Rockwell Space Division, assembly and checkout of S2 stages continued during the report period. Post-manufacturing checkout of S2-12 was completed in December, and the stage was shipped to MTF for acceptance firing. Systems installation was progressing on S2-13. The liquid hydrogen tank for S2-14 was damaged during detergent cleaning operations in October, when a spray nozzle detached and fell about 45 feet, causing a small hole in the forward bulkhead. Repair was effected by use of a doubler. A pneumostatic test was successfully conducted in mid-November. Life cycle tests of the foil seal and doubler repair were also satisfactory. No S2 stage delivery impact is foreseen. S2-15 had completed vertical assembly operations and was in the pneumostatic test and cleaning phases near the end of the report period. Production of S4B stages for Saturn V flight vehicles continued during the report period by the contractor McDonnell Douglas at its Huntington Beach, California facility. Painting of S4B 512 was finished in November, and the stage is now in storage. Post-manufacturing checkout of S4B 513 neared completion. Assembly operations continued on S4B 514 with tank cleaning underway on 515. Fabrication and assembly of Saturn V instrument units is progressing at IBM Huntsville. In late October, a request for quotation was issued to IBM by the Marshall Center for 6 instrument units for the Saturn V follow-on program, launch vehicles 515 through 521. RFQs for the 6 S1C, S2, and S4B stages were issued in November. Efforts by Marshall and contractors to procure reduced-cost vehicles for the follow-on program are progressing well. The basic concept for this procurement is to phase from an R&D mode to a production mode and procure the vehicles on a fixed-price contract. A follow-on reduced-cost procurement plan for 30 F1 engines and the combination of 36 J2 and J2S engines from Rocketdyne is being studied by NASA. Batching of F1 and J2 production to better utilize production machine capabilities, combined procurement of raw materials, and revising mode of operation from development production to production only are expected to contribute significantly to reduced engine costs. This is an artist's concept of the lunar roving vehicle, for which the Boeing company was selected by MSFC in November to be prime contractor. The LRV will provide transportation on the moon for 2 astronauts and their collected lunar samples, equipment, and experiments. This is a full-scale mock-up of the moon car. The LRV will be needed for extended scientific investigation of the moon. The first of 4 operational LRVs will be delivered by Boeing in 1971. The 4-wheeled vehicle will weigh approximately 400 pounds and will be about 10 feet long and 8 feet wide. Electric motors will drive the LRV, with silver zinc batteries providing power. Top speed will be about 10 miles per hour. Preliminary design and definition studies for a dual-mode LRV, which could be either manned or unmanned, will be performed by Grumman Aircraft and the Bendix Corporation. The dual-mode vehicle could be operated remotely from Earth while making long-range automated traverses across the moon. With the report period just ending, the Saturn V launch vehicle has helped achieve the historic culmination of a decade of national effort and the dream of centuries. Man has walked upon the moon. This is but the beginning of a new age of space exploration for the benefit of mankind, in which Saturn will continue to play its vital role.